These are the instructions for Lab 7, Air Masses, Mid-Latitude Cyclones, and Weather Maps. It's a rather long and involved lab, so there'll probably be 2 videos for the lab. The first page asks you about air masses, and I encourage you to watch the 2 Meteo videos 6b.1 and 6b.2, where I explain air masses and cold, warm, and occluded fronts. This is a big part of the beginning of the lab. I'm not going to explain these features because I do quite an extensive job of explaining them in those videos. If you haven't watched them yet, you probably want to watch them before you do this part of the lab. So this figure is showing you various air masses that affect the North American continent. The first question asks you to describe the temperature and humidity conditions associated with the 4 basic types of air masses. So let's do the first one together. It asks you about a CP air mass. And as described in this paragraph up here, it tells you what these various letters mean. C means that it's a continental air mass forming over the continent, and thus it's a dry air mass. So we put dry. The P refers to the fact that it's forming far from the equator, and so it's cold or polar. And so we add that it's a cold air mass. So you're going to do this for the other 4 main types of air masses. Question 2 asks about air masses that have the greatest impact on the Pacific coast of North America. I think this is pretty straightforward. Just realize that this is the area they're talking about. And question 3 asks about the southwestern United States and northwestern Mexico, and they're asking about this area right here. It continues on the next page with a few more questions about air masses that originate in various areas. So you just need to be familiar with where you are on the map and which air masses are affecting different areas. The bottom part of this page talks about cold fronts and warm fronts. Activity 2 actually refers back to this original figure. The first question says, on figure 1, draw a line where the continental polar air mass, so that's this one, and maritime tropical air masses, that's these right here, are likely to collide, and as a result, where a front is likely to develop. Remember, a front is where 2 air masses meet. And so even though these 2 air masses meet here, they're separated by these mountains. So the mountains are going to complicate things. But right here is a more likely place where there's going to be a front that isn't going to be complicated by the presence of topography. So this is where you're going to put your line. It then asks, will a continental polar mass be more likely to be found north or south of that front, east of the Rocky Mountains? And so again, these are the Rocky Mountains. And so they're talking about this imaginary line that you put. Is the continental polar air mass going to be north or south of that line? And what about the maritime tropical one? So these questions sound complicated, but they're really quite easy. Following questions then refer to figure 2, which is the cold and warm front figure, and figure 3, which is at the top of this page, which shows the development of an occluded front. Again, if you watch my video on fronts, I think that all of these questions will be pretty straightforward to answer. So now you can see that whole page. Here's activity 2, here's the development of the occluded front, and the questions continue on the next page. I show you the symbols that are used in weather maps for cold fronts, warm fronts, and occluded fronts, so you can get the answers there. Activity 3 moves on to a mid-latitude cyclone. I'm going to blow up this section at the bottom of the page here, over here. And I've also shown you the next page, which shows you a map of a mid-latitude cyclone. The first question says, are the surface winds in a cyclone converging or diverging? And I just want to remind you that converging means winds are all blowing towards each other, and diverging means winds are blowing apart. The center of the cyclone is right here, where you see the low pressure. So I'm going to let you answer these next 2, but I think you can do it. Is the air in the center of the cyclone subsiding or rising? So here's the center, and it's low pressure, so that should give you a big hint. It also says on figure 4, which is this figure, label the cold, warm, and occluded fronts. So knowing the symbols, that should be pretty straightforward as well. On the bottom of this page, there's question number 4, and I've blown it up over here. Which location, and there are locations A, B, C, D, E, F, G, H, indicated here, is most likely receiving precipitation associated with the cold front, warm front, occluded front? So for this question, you want to look at these cross sections. At the top of the page, you have this cross section across F, G, H. It's basically a side view, and you can see where the air is cool, cold, and warm. You can see where clouds are, and the various abbreviations for the clouds are defined down here in the key. And you can see where rain is occurring. A cross section from A to E is down at the bottom of the page. You can see various fronts, air temperatures, and cloud types. So, which area is receiving precipitation associated with a cold front? Well, this right here is actually blown up here, and here's the cold front, and it looks like D is pretty clearly getting precipitation associated with the cold front. So that would be D. And I'll let you do the other two. Let's look at the next page, page 177. This is one that gives students a lot of trouble. Whenever they see a big page with lots of questions, they kind of freeze. But these questions aren't that hard, it's just that there's a lot of them. So let's work at some of these. Question 5 says, considering the air mass types. Well, let's stop right there. What are the air mass types in this picture? Well, we have CP, continental polar, we have MP, maritime polar, and we have MT, maritime tropical. So back to the question. Considering the air mass types and their locations in the mid-latitude cyclone, describe the likely weather at each location listed below using the two following words: cold, cool, warm, dry, and humid. Let's start with location A, which is right there in the map. So let's start by looking at the water content. Because the air mass where A is has an M before it, that's maritime, and maritime means humid. Remember, C, continental, means dry, so we know that A is in an area with humid air. What about the temperature? The air mass has a P, and P means polar, so we know that's cold. T would mean tropical, and that would be warm. Should we put cold or should we put cool? Well, either one would really be correct, but if we look down here, A is in cool air, warm and cold air are over here, so really cool would be the best answer. You're going to do this same logic with location C, E, F, and H. Question 6. Describe how the barometric pressure will change at point F as the mid-latitude cyclone moves eastward. So here's position F. And what you have to realize is this entire weather system is going to move over the country from west to east. And so if we look at these isobars that list the pressure, and position F, of course, is going to stay where it is, these isobars are going to move over it. So currently its pressure looks like it's about 1014 millibars, and then the 1012 millibar will pass over it. Eventually the 1008 millibar will pass over it. So the air pressure is going to drop. It's going to become lower as the mid-latitude cyclone moves over it. Now, this is sometimes hard for students to imagine, so I've done something in the next slide here. I've highlighted, for a purpose you'll see in a second, the isobars and the fronts. I've made them kind of cartoonish, but I want to show you over time how this entire mid-latitude cyclone moves. Remember, I said it moves west to east, like this, and it also turns counterclockwise because it is a cyclone. So you can see how F has been passed by lower isobars. And so that's how you have to imagine the future of each of these cities. They're going to experience a change in the directions I just showed. Let's look at that again. Okay, so I think that answers question 6. Question 7, describe how the wind will shift as the cold front passes point D. So here's point D, and the winds are shown with arrows. Up here, the winds are coming from the northwest, so we call that a northwest wind. Down here, the winds are coming from the southwest, those are southwest winds. So D is in this section, it's currently experiencing southwest winds. And once that cold front passes, which you can see is going to happen very clearly down here, the winds are going to change from southwest to northwest. The rest of these, 8 through 13, I think are pretty straightforward. They're going to ask how temperatures will change when a certain front passes, or how water vapor will change, and that you can say by looking if it's currently raining, is it going to be drier, or if it's currently dry, is it going to be raining? Question 14 is a little bit overwhelming because they're asking you to fill out this complete table here. And you're going to provide the conditions right now at the various stations A through E. So let's go ahead and do A together. What is the current temperature? Warm, cool, or cold? Well, we actually did this up here. Cool. What about the pressure tendency? Is it rising? Is it falling? Is it steady? Well, remember, this entire system is moving to the west. So region A is going to experience a drop in pressure as these lower pressures move over region A. So the pressure is going to be falling. What about the wind direction? Well, A is in this region where we have winds coming from the southeast. So the wind direction is southeast. What about the cloud type? Well, in this case, we need to look at this lower diagram. And A is overlain by CI or cirrus clouds. And then finally, precipitation, yes or no? According to this bottom diagram, no, there's no precipitation over location A. And so you're going to do that for B, C, D, and E. It takes some time, but it will really help you start to learn how to read a map and how to read these variables. Then when you get to question 15, it says refer to this completed table and briefly describe the temperature changes that occur at point A as the mid-latitude cyclone passes. And what that really means is A is going to be in the position of B and then C, D, and E as this entire system moves from west to east. So the temperature change that's going to occur at A is going to really be this sequence that you find in this column. Whatever happens at B and C and D and E are the sequence of temperature changes that A is going to experience. In the next video, we'll start looking at station models.